Hello, everybody. All right, so we are going to be doing a topic called proofs involving congruent triangles and segment or angle bisectors. Kind of a long one there. But first of all, always look at the titles. The titles give you clues what you're going to be doing. So the word proofs, that means we're going to be proving something. So we always have something that looks like this. Statements. Sorry, a little sloppy there. And then reasons. On some of the videos too that I found for some of the other people, they also have another section here that's called lines. And with that one, they're referencing which line, which statement they're talking about for the reason. That's not always necessary, and Alex isn't necessarily going to ask you to do that, but it is important to understand why you were able to go from step to step. Now, in a proof with statements and reasons, normally what you do in math is you just make a bunch of statements where you're going down and doing a problem. So if I give you something like this, and this is just an example, equals, and I'm just making this up, so we might even get a decimal here, just making numbers up. So we get 2 times, and I'm going to change this to an x just so that I can go through here. 2 times 5 plus x equals 10. Well, normally we just go, okay, well, I'm going to multiply by 2 on both sides. Or you could even distribute, actually, the 2. So that's probably the normal route that most students would take, so I'll do that instead. You can do it either way, honestly. So you would distribute this 2 like this, and you'd have 2 times 5 gives you 10, plus 2 times x gives you 2x equals 10. And then you'd subtract 10 from both sides, and you'd end up with 2x equals 0, because 10 minus 10 is 0 on this side, 10 minus 10 is 0 on this side, divided by 2, to get x all by itself here at the bottom, we'd end up with 0. These are a whole bunch of statements. I've just gone through all of my steps. What a proof means, the reason section, is that I'm explaining why am I doing what I'm doing. So in this step, I would write distribute. I'm distributing. Distribute, distributing, distributive property. You can write a few different things on there. Alex will have a drop down so that you can choose from the drop down. So I distributed the 2. And then in here, I'm using the additive property of, I want to make sure I'm saying that right, additive property of addition, because I'm adding or subtracting the same number from both sides. So, that would be my reason for this one. This would be the multiplicative property of division, because I'm multiplying or dividing something on both sides. So it just depends on what it is that we're doing. Each one will be given a reason. Usually your very first reason is going to be given. It was given to me. So usually we'd have the equation just written out at the top without anything done to it, and that's given. It's just exactly what I was given here. I'm going to erase all this. So again, that was all just examples. We're not working that problem out. Hopefully that wasn't confusing. I just want to make sure you understand what statements and reasons mean. So normally in math, we go through and make all those statements, but we don't stop and say, why am I doing what I'm doing? In a proof, once we get to geometry, that's what we need to do. We're not necessarily going to be doing full calculations, but we're going to be going from logical step to logical step based on given information. And we need to state, how do I know to go from this step to this step? What definition or property or theorem, what lets me move from step to step? So first, before we jump into the proof here, we're going to jump in just a second. I want to make sure that we understand. So this is the explanation page on here, and it says, in these proofs, we will always need to prove that 2 triangles are congruent. To do this, we will use one of the following congruence properties. So there's a few of them. We have side, side, side. That's what SSS stands for. It means all 3 sides of one triangle are congruent to all 3 sides of the other triangle. We have side, angle, side. So when we look at a triangle like this, we go side, angle, side. It has to go in order like that. You can't skip over and go side and then this angle and then this side. It doesn't work like that. Okay? It has to go right in order. Side, the very next angle, the very next side. And then in order to be congruent, and I know those aren't drawn congruent, but we're going to pretend, this one would also have to have side, angle, side like that. Does it have to be that way? Could it be turned sideways and go side, angle, side? Sure, that's fine, as long as I can follow that same pattern of side, angle, side. So angle, side, angle, it's very similar to these ones, except I'm going to go angle, very next side, angle. And then same thing, if I had my other triangle here, I can go angle, side, angle. Again, doesn't have to be the exact same side as far as the orientation. It just has to go angle, side, angle. As long as you can follow that pattern, it works. And then we also have angle, angle, side. So in that case, we would go angle, angle, side. So we actually skip a side here. We go angle, next angle, side. So that's what these mean, these letters: side, 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 angle, side, angle, side, angle, 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 side. So those are important. If you don't know them, you definitely would want to look them up. So that's another big thing, is making sure that you're looking things up. It should be in the explanation page, but I don't even think the explanation page actually goes through and defines these for you. They're just reminding you that we're going to use them. Definition of a segment bisector. So if it's a segment bisector, well, that was a really ugly underline, then it's bisecting, cutting in half a segment. So if I have a segment bisector, I'm just going to draw one here like this, and I say this is a segment bisector, it means it's cutting this segment on the bottom in half. That means this side is equal to this side on the bottom. So this line is equal to this line. Or this is a midpoint. That's another way to think of it. So that's what a segment bisector means. It's a line that's cutting another line in half. Angle bisector, so I'm going to draw that on this one. So we have another line like this, but instead of cutting the line in half here, even though it might look like it is, we're cutting the angle in half that it's coming from. So angle bisector, cutting an angle in half. Midpoint, which I was just saying too, if it's a segment bisector, that is a midpoint. It's in the middle of the line. And then properties of vertical angles. So vertical angles is anywhere where you have something like this, where it crisscrosses. And on some of these, you're going to have a triangle that looks like this, where you'll have triangle kind of on the top and the bottom. So we have this kind of X or crisscross. Vertical angles mean that you're going across the vertices. And these angles are congruent, always. They are always congruent, and it is one of the simplest things to grab whenever you have this situation. So every time you have that crisscross, vertical angles, meaning, doesn't mean they have to go vertical, meaning up and down, it's across the vertices. So it's a little bit of a misleading name, but that's how that works, okay? So now that we've gone over all that, let's go ahead and actually take a look at our proof here. It's not a very long proof. Most of these have only a couple of steps to them. So one of the nice things about Alex is that you'll have a button here that says send proof for the given. So we have one piece of given and we have another piece of given. We have two of them. Make sure you put both of them on the proof or it'll mark you wrong. The thing too, it won't let you move forward to the next piece unless it gets what it's looking for. So the proofs aren't usually the bad ones where it's giving you a point, taking a point away, because it'll tell you, nope, that's not the accepted next step, try again. But it's not taking that point away, it's just letting you know that step won't work. So you put something in to the proof, that step for this statement of reason, and then you check. If it's good, it'll move to the next line. If it's not, it'll go to-do or make some kind of little noise, I think, and have you try again. So we're going to send these to the proof here. And again, there's a little button that helps you do this. So we're going to use these given information pieces to prove that the triangle DGE, which is this one, is congruent to the triangle FGE. And I know I didn't draw that line very well. Pay attention to the order of these. That is very important, and I've had this conversation with many students before. They're corresponding. What that means is that F corresponds, or sorry, D, I put it above D. D corresponds with F. G corresponds with G, and E corresponds with E. Doesn't always mean they match. In this case, they are matching because they share this line in the middle, but they don't always match. Sometimes the letters are a little out of order there, but it's mainly first, second, third, first, second, third. They should be corresponding, meaning congruent angles. Or I can even look at segments in this case, and I can go DG is congruent to FG. So it matters. That order matters. Pay attention to that order. All right. So one of our first steps is definitely to mark the given and then put it in our statements. So with this one, we have DE is congruent to EF. So we have a segment congruent to another segment. So we have DE, here's DE on the top, and I'm just going to mark it with a tick mark. And then EF is this other segment here on the side, and I'm going to mark it with a tick mark. When you're marking congruence, it's one tick mark to one tick mark. That means they're congruent. If you have another segment congruent, then you go 2 to 2. And if you had another one, 3 to 3. So you just keep putting more tick marks on here to match. So the matching tick marks let you know that they're congruent. That's what that means. When you have angles, and I did that on the other screen, it's arcs like this, okay? Which is actually our next step here. So it says EG, which is this line in the middle, bisects angle DEF. So make sure when you're looking at angles, you're following the path they're giving you, DEF. So DEF. So the angle is the letter in the middle usually. They have to give you the 3 letters because we can't just say angle E. That could be this portion here, it could be this little portion here, or it could be the whole thing. So they have to give you all 3 letters to indicate that it's the whole thing. So if it bisects DEF, that means that this angle is congruent to this one, just like I marked. So one arc to one arc. If you had more angles, you do the same thing as the tick marks. 2 arcs to 2 arcs, 3 arcs to 3 arcs. So you just match up. 1, 2, 3, 1, 2, 3. All right. So now that we've marked our diagram here, we're going to put this in our proof, like that. So my reason is that it was given to me. And then I'm also going to do this one. Again, you can just simply click the send to proof button, which is nice. So it goes a little faster than writing it out here, DEF. Again, my reason is given. So you just put 2 lines in there. And the reason for the 2 lines is that it was given to me. It was given to me again. All right. So now that it was given to me, and one thing I do want to point out, they gave you that EG bisects angle DEF. They didn't give you that this angle is congruent to this angle. We have to use the word. Whenever they give you a word like this, you're going to have to use that definition in order to take that next step. So our next statement here, and I'm going to number these. Sorry, it's going to go right through my arrow there. So my next statement here is literally going to be to say that these angles are congruent to each other. Might seem a little redundant, but they haven't given us that yet. We need to state it. So how do we know that they're congruent? The word bisect. So we're going to go DEG. So we have DEG. Sorry, I should have put an angle on there. Is congruent to, and make sure you're paying attention to the order. Don't go GEF. It was D and F. Those are corresponding, just like here and here. So we're going to go FEG. If you notice, we're actually writing out almost the proof, but in this case, sorry, I forgot the angle mark again. We're doing angle instead of triangle. We're not quite there yet. So the reason for this one is literally, it's the definition of angle bisector. And a lot of the time, we tend to shorthand a lot on the proofs, but you'll have a drop-down menu and you just choose definition of angle bisector. All right, so number 4, now that we have, we know that this segment is congruent, this segment's congruent. They did in fact give us that. We don't have to do anything else to prove that. And now that we've stated, okay, we have 2 angles congruent to each other, remember, we can use either side, 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 angle, angle, or angle, angle, side. We have to use one of those 4. There's actually another one, but it has to do with right angles, so it's not going to apply here. Because, or it could actually, this is a right angle, but we haven't quite started that yet. So that one is, I'll go ahead and throw it down here, HL. So hypotenuse leg. But we don't quite have that yet as far as the definitions go. We haven't started using it. So side, side, side means that all 3 sides are congruent to each other. And so far we only have one side and we have an angle. So we're more than likely going to use one of these 2 because we already have an angle involved. It could even be this one, angle, angle, side. but we don't necessarily know that this is 90. I'm kind of guessing. That looks like a 90. Don't guess. Don't assume that it's a 90-degree angle just because the diagram looks that way, okay? That's another big mistake that I've seen students make. Don't make assumptions. Go with what you're given. Look at the information and how do I get there? Can I prove it? All right, so one big one, and you're going to use this a lot, especially when they have a shared line like this one. We know that the line GE is equal to itself. Both triangles have that line GE in them. So we can say that this line is equal to itself. So GE is congruent to GE. It's congruent to itself. And the reason for that is reflex or reflexive property. So we use the reflexive property whenever we have a shared statement or a shared segment, reflexive property. It's equal to itself. GE is congruent to GE. In this case, of course, it's not always going to be GE. So now I have side, the next angle, the next side. Now I have side, the next angle, the next side. I can do it in both triangles. So I can use side, angle, side. I'm just matching it up. I'm literally reading it on the chart here. Side, angle, side. Make sure with those ones you're not skipping. The only one you kind of skip a little bit is angle, angle, side, because you're going angle, next side. So you do skip one side in that one. You skip the side in between these two angles here. So my very next statement here, I can write down my prove. And again, I believe there's a button that says send approve. So you just click it and it goes right down there for you. So you go triangle DGE is congruent to triangle FGE. And the reason for that, we just simply put side, angle, side congruence. And again, you're going to pick this from a dropdown, so just make sure you read through the dropdowns and you're picking the correct ones. And each time you put a line in here, you have to click check. And it's going to let you know if that line is correct, and it'll let you move down to the next line. Most of these proofs will be, 3 to 5 steps. They shouldn't be terribly long. So the only other one that might come up, because it was segment or angle bisectors, we did an angle bisector. So it might say, e.g. bisects segment DF. Well, then we just go a different route. Now we would know that it bisects this bottom line. So instead of having these angle markings, we would have the tick marks down here, as well as what other given information they gave us. So again, pay attention to given information, mark it on your diagram, and then work through it step by step. How do I know angles are congruent? How do I know segments are congruent? And then try to get to one of these ultimate goals of triangle congruence. So we want to meet one of these goals. Again, we do have the HL, but we don't use it terribly often in this program. So, all right, I hope that helped, and I will see you next time.